In this chapter, we've gone back and looked at statistical inferences, which means that we have the data, but we need to infer something from that data. Usually what we're looking at is, has something changed? This is the very last one of the videos in that series. It's on hypothesis testing. Hypothesis testing is the most formal way that we can go back and look at whether something happened or not. So the example that we've been continuing to talk about has been our coffee shop, where it used to be an average sales of $4.18 with a standard deviation of 84 cents. We changed something with the promotion. We've gone back, we've sampled 50 customers. The new sample says that we've gone from the old average of $4.18 up to an average of $4.52 per customer being spent with a standard deviation of 71. What we want to know, truly, what we want to be able to determine is, did something change? All right? From a hypothesis testing concept, what we're really saying is it any longer $4.18? All right? So we state two things. We state what we call the null hypothesis, and the null hypothesis basically says, nothing happened. The average is still $4.18. And along with that, we look at an alternative hypothesis. The alternative hypothesis is that the average is no longer $4.18. Let's go back and look at it from a confidence interval type idea. All right? So once again, $4.18, have we really finally gotten larger than $4.18? Or have we gotten smaller than $4.18? We do a hypothesis test doing 4 steps. We state the null and alternative hypotheses. We specify the significance level. Again, most of the time we're going to use an alpha of 0.05. Okay, that's the significance we're talking about. We calculate the T statistics. We look up a p-value, and then we state the conclusions. Very similar to what we did with confidence interval. Very similar formulas, okay? First of all, state the hypothesis. The null hypothesis is nothing changed. Alternative hypothesis is something did change, all right? We're using a significance, alpha of 0.05, but you can see we're doing a two-tail. We're not saying that it is greater than 418, and we're not saying that it's less than 418. We're just saying that it's not 418. So that means with a 95% confidence interval, I have 2.5% in this tail, right? Because I'm looking at the overall 5%, 2.5% in this tail. Calculate the T statistic. The T value for degrees of freedom 49, all right, once again, this is the degrees of freedom idea. We know the degrees of freedom is sample size minus 1. So the T statistic for 49, because we did a sample of 50, is the new average minus the old average, or the average associated with my null hypothesis, divided by the standard deviation of the sample, and then the number of items in the sample. So my T statistic here comes out to be 3.39, so I label it 3.39 on my graph. And then I look up my p-values, okay? P-values, we're going to use the student T distribution, and let me bring that up for you real quick. We didn't go in and look at this before, but in the back of your book, table D2, if you look up the degrees of freedom, 49, okay, and we look up here at our alpha value, we know that our alpha is 0.05, but it's in two tails because we're saying it's different. We're not saying it's greater than or less than. So if the alpha is 0.05 and we're talking two tails, I'm really looking at the 0.025 in each tail. Okay, so I'm looking down this column, 0.025 for alpha, degrees of freedom 49. My p-value, therefore, is 2.010. Back here, p-value 2.01, the zeros behind it. I'll mark that over here for my area that I'm interested in. So you can see that the value that I just calculated for my t, this is my new, it's really kind of a z standard. It's a z statistic. It says I'm really 3.39 standard deviations above the mean. I only needed to be 2. So therefore, something really has happened. This has shifted significantly. Conclusion, therefore, is that since the t-value is greater than the p-value, in statistical language, we say we reject the null hypothesis. The null hypothesis is that it lives somewhere in this range. We have just gone through and found no, it really lives over here in this range now. So we reject the null hypothesis, which means that since we reject the null hypothesis, that means that the average is no longer $4.18. In practical terms, what it's saying is that the new average is statistically significantly higher or different than the old average. Okay, let me bring in one more idea for you as we do this. It is possible to just look at one tail. Okay, we can look at just one tail. In particular, we could go back and say we really don't want our sales to be less than $4.18 after the promotion. We really want to believe that it is higher than $4.18. When we shift to one tail, what ends up happening when we shift to one tail is that when we use the alpha level, all 5% of this alpha ends up getting shifted just into one tail, right? If I'm still using an alpha of 0.05, but I'm using a one-tail test, my alpha is really 0.05, which means now that whenever I go look this up in the student T table, I'm looking up 0.05 in the tail with the same degrees of freedom. So my p-value goes to 1.677. Okay, so that's the ideas behind the null hypothesis. Just a more formal way for me to be able to go in, take a look at whether or not the world has changed.